Hi viewers, we want to look at the period for a satellite to revolve around the earth, and that formula is giving us T equal to 2 pi square root of r cubed all divided by gm. Today we want to look at how we can prove this formula. Alright, let's come here and see something. Now let's consider this as our earth, this as our satellite with mass small m, and the mass of the earth is big M, and the distance between the center of the earth and that of the satellite is represented by big R, with the velocity v or the speed v of the satellite revolving around the earth. Viewers, now from Newton's law of universal gravitation, there is a force of attraction that is existing between these two bodies, all right? And that force of attraction is proportional to the product of the individual masses. So we have big M, small m, and inversely proportional to the square of the distance between them. So all be divided by this, the distance r, so square of the distance. Now we can have our F equal to big G, big M, small m, all divided by r squared. And this is the formula for Newton's law of universal gravitation, the force of attraction that is existing between these two bodies. Now, this force of attraction provides what we call centripetal force, which keep this satellite to be in motion around the earth. And mathematically, our centripetal force is equal to the mass of the satellite multiplying the velocity squared divided by the distance, which is r. So this is the universal gravitational force, and this is the centripetal force. Now, for this satellite to revolve around the earth, the gravitational force must be equal to the centripetal force. Therefore, we can say that Fg should be equal to Fc, viewers. Then Fg is big G, all right, big M, small m, all divided by r squared should be equal to mv squared, all divided by what? R. Viewers, this m will cancel this m. Then we can have v squared divided by r equal to big M, big G, big M, divided by what? Our r squared. Viewers, what we have here, we multiply both sides by r, all right, by r, and this will cancel this, and we have v squared equal to this will cancel this, we are going to have r, so we have big G, big M, all divided by r. And we name this equation 1, viewers. So v squared equal to gm all divided by r. Now, since the satellite is revolving around the earth, we can say the speed or the velocity of the satellite. And viewers, we know that velocity is equal to displacement over time. But here, the distance here or the displacement we are going to talk about here, because the earth is spherical, the distance around this is going to be the formula for the circumference of a circle, which is going to be 2 pi big R, okay, where R is the distance between them, all divided by the time, and the time we use the period, so capital T, as we can see. Then we name it equation what? 2. Viewers, we are going to substitute equation 2 into equation 1. Anywhere we see v, we move the whole of this, then we fix it here. So viewers, we have 2 pi big R, all divided by T, all raised to the power 2, okay, equal to Gn, all divided by what? R. Viewers, we expand this, and we have 4 pi squared, R squared, divided by T squared, equal to Gm all over R. Viewers, we are going to perform cross multiplication, where this will multiply the whole of this, and this multiplying this, viewers, we have 4 pi squared R cubed, all right, should be equal to T squared Gn. We divide both sides by Gn. Divide here by Gn, viewers. This will cancel this. Our T squared will be equal to 4 pi squared R cubed, all divided by Gn. Now we are looking for T, so we find square root of both sides. So our T will be equal to square root, viewers, of 4 pi squared R cubed, all divided by Gn. Viewers, from what we have here, we can find square root of 4, and it will give us 2. Square root of pi squared, it will give us pi. All right, outside the bracket, then we have R cubed, all divided by Gn. And this is the formula that we are looking for. Viewers, I hope you enjoy it, and watch out for more formulas on this. Thank you.